Hello, today we are going to talk about floppies. Not that floppy, it's not even floppy, so it doesn't count. But the actual real floppy thing, and so that's the 5¼ inch, but that's the one for babies. We want to talk about the one for adults, the 8-inch floppy. There you go, it fits. So that's how the floppy was born. This is the original format from IBM.
Well, hello and welcome back. If you follow the channel, you know that we had a previous run-in with 8-inch floppy drives when we helped paleontologists recover a trove of fossil data locked into what turned out to be the very first IBM floppy format for IBM 360 mainframes. And during that adventure, we also befriended the multi-talented Antoine, part paleontologist, part musician, and part retro computing enthusiast. We even visited him later in Paris, where he showed us his amazing chip collection. Antoine has now become a member at large of our little team.
So you know that we have had a run-in with those previously on the channel, but the reason I want to do it again is because I want to revive the HP version of those floppies. There is the 9885. It was introduced specifically to support Mr. Fancy Pin's favorite machine, the HP 9825. You get it, right? 9825, 9885, they go together. And then it evolved into this big monster, which is the 9895, and that one is meant for the mini computers, the small mainframe machines that they had. It has an HPIB interface, which means it can connect to almost everything. It's a little bit of a universal floppy, which is why it's very interesting to get one. And I lucked out because I got a pile of them during my last haul from LA. It was a few years ago, so it's about time we start working on them. So inside of that big monster of the 9895 unit, there are two drives, also monstrous, and I have taken one out over here. So that's the HP one, and actually this is one of the original IBM ones, and that we should talk about this one first. So you might or might not know that the floppy was invented by IBM, and it was originally introduced as a read-only media, so they could load their boot microcodes in their bigger machines. Distributing microcode had always been a problem. This was actually a cost reduction for distributing firmware. They eventually made a read-write version that a customer could use. And this one is one of the early ones. This is a 31SD, and you can see it as a single head. This is just a pusher. So this is a single-sided disk. It's also single density. The early ones don't have a DC motor. They have an AC motor that's always on. And then you have another huge motor, which is the stepper motor. So that's the stepper motor to move the head, and that's the motor to spin the disk. They have this proprietary interface. And next to the IBM, I have put the HP version. It's actually not HP. They bought it from somebody else. You can see it's similarly built. It has this huge AC motor, and it has this very large stepper motor. But here it's a double head. There's a head on the top and on the bottom. And also, where I'm telling about single-sided low-density drives and this double-sided drive, I have to mention that there are 4 different types of floppies. There's the original one, type 1, which later got called single-sided, single-density. So this one has only one side, and it can hold about 300 kilobytes. Then IBM came up with a type 2, it says diskette 2. And this one just has 2 sides, so it holds double the amount, so that's about 600K. And then they came up with their next trick, which consisted of changing the encoding, and the rich double density. They need better media to do that. So this is a type 2D, the double-sided double density, which now has a very respectable 1.2 megabytes of data. And there was a money pincher somewhere that also invented the single-sided double density. So I've taken the double density and the single density out of their pockets. The index hole in the double-sided is off to the side, whether the index hole in the single-sided is closer to the center. So that's how you can tell. This is a little hole that comes once per revolution and tells where the track begins. This one can only do the type 1 diskettes, so single-sided, low density. This one is actually a universal one. It can do single-sided, double-sided, low and high density. Also, this one has now the standard Sugart 50-pin interface. That's from Al Sugart, who is the person that headed the team that developed the original floppy. And then when he went on his own, after IBM was forced to open up their ecosystem, he standardized the interface, and it's called the Sugart interface, and we still use a descendant of that in the modern floppies.
So theoretically, since this HP drive, which we'll see is not an HP anyhow, has more or less a standard interface, we should be able to hook it up to a PC to test it. However, it turned out to be quite difficult, and we'll show in the rest of the video how and why we had to develop a complicated adapter cable. But here is the good news. Antoine has transformed this unwieldy cable into a nice little adapter available on Tindie. On one side of the adapter, it has the 50-pin edge board connector for the 8-inch disk drive, and on the other side, a regular 34-pin connector that will plug into your computer floppy cable. It still has a whole bunch of options that have to be jumpered carefully, but Antoine has made a manual for that, and in this video we'll explain all the silly details. By the way, that's the same adapter that Adrian used to connect his drive to a PC in his 8-inch floppy video. So we have proof that it works for more than just us. But yes, you can connect an ancient 8-inch drive to a PC and boot from it.
I think it's booting. Welcome to DOS on an 8-inch floppy diskette. Directory. Ta-da! And so this one is maxed out because I put a Donkey Kong on it. It's loading.
And if you really want it, you can play your favorite DOS game right from the diskette.
See how far I make it. Probably not very far.
Or use it from within Windows 98 instead of a boring 3.5-inch floppy. We are of course going to use this for an entirely different purpose, to test our HP drives and to recover and recreate old 8-inch disks in non-native PC format. So here's the story of how we did it. It starts quite a while ago when Antoine was visiting and Carl had not yet moved to Florida.
Flexible disk memory. It's not hooked up to anything. Here's the power.
That's an interesting sign, and this looks like it's not flush, so it might even be
Yeah,
loose.
this one moved. No power up test drive 1, so that one is not happy.
Oh, like the magic smoke escape.
It's time to extract the drives and do some inspection and cleaning.
So what we have figured out so far, that's how the heads load. This we have to unbend, because this thing is all bent downwards. I want to clean the heads. So this is a CDC drive apparently. Where was it written? It's Magnetic Peripherals Inc. Control Data Corporation. This is Oklahoma City Operations. This is from Oklahoma. Well, that's definitely seen better days. There we go. Yes. That was very needed. Oh, binds. What binds? Antoine just found what's not right, and there is a little piece of
plastic that's broken, and that's broken in 3 out of 4 motors that we have checked so far. So it's an endemic problem. Then at the back it needs, we have the mains, which is the beautiful safety proof everything, and then you have 24 volts and 5 volts. Smoke test.
Smoke test.
But I push it like this.
Yep.
And this is a line.
Yep, then it's good.
600 milliamps. No smoke. 24 volts. 42 milliamps, so nothing.
Yeah, that's good. Spins.
We're spinning. Okay, try the hook it up to the computer.
I guess so. Next step.
And that's where things started to get more difficult. See, the original 8-inch Sugar interface has a 50-pin connector and is fairly well thought out. But later on, the interface was condensed to make it fit on a cheaper 34-pin connector, which is this pin out. And then, horrors of horrors, the IBM PC folks introduced the ignominious cable twist. That was very much in keeping with the spirit of the original PC, which was a bunch of hacks hastily cobbled together rather than a properly engineered machine, which later caused endless suffering. Anyhow, I had to come up with a way to fit 50 pins into 34 pins, and after a bit of head scratching, I came up with my own ignominious one-day hack, back when we were trying to read our fossil data diskettes for our scientists. Mind you, just like the PC, it looked quite bad but worked quite well. So I figured it should just be a simple case of reusing the same cable with our HP drive, and we'd be up and running in no time.
There you go. It's just a bit stiff.
In Dolch we trust. What happens here? So from previous experience, our cable should be good, but will the drive appear as A or B? With the various BIOS settings, the drive's unknown configuration, and the ignominious PC cable twist, it's anyone's guess. But if the BIOS is configured for both drive A and drive B, it should attempt to seek either drive at boot. Okay, there you go.
Yeah.
Hard up. Floppy disk fail. Floppy disk fail is not good, but it could be just that we configured it as the wrong thing in the BIOS, or the computer controller can't recognize 8-inch drives. More worrying though is that we did not hear the drive seek. But I didn't hear it. Here the splash screen says Windows 98, but I am just booting to the pure DOS stage so I can run my favorite DOS tool, OmniDisk.
Yes, then a blender.
Okay, OmniDisk. Oh, drive 1. There you go. Seek 20.
Huh.
Time's out.
No, it did not do anything.
Scan.
Not happy.
No. So try number 2 with the other disk drive, which doesn't have the plastic part broken.
The ejection mechanism is better too.
Right.
Like
Yeah.
mains.
Yep.
Right.
Okay, smooth. We just had a seek, I didn't capture it. Okay, this drive is more promising. It seeked during the early BIOS boot process as it should. And then while I was issuing seek commands with OmniDisk, something happened.
Yeah, wait.
Did this just go?
Is there a logical address on this drive?
Do it again with a higher level.
Drive 1, seek like 60.
Now what I meant was go back to drive 0 and do the seek to a higher level.
Drive 0.
Yep.
Oh yeah.
So they're both drive
both
0.
A, they're both, yeah. So that's the jumper that are it's hardwired there on the board.
Yeah.
Okay. All right. So low. Alright, we got some action, but apparently both my internal drive and the 8-inch drive think they are disk A, which is drive 0 on Omnidisk, so that's an issue.
We're having some better luck. We disconnected the internal disk drives, so now I can seek to 60. Yay! Seek to 0. Alright.
But also, I wonder if the heads are loaded or not.
Ah, I didn't load the head.
Oh,
Okay, so we're missing a signal, probably.
Yeah, there's probably something extra with the head load.
So the seeking works, but then it can't read any signal because there is no head loaded, nor probably no the read amplifier is not engaged. On your other disk, it worked all by itself, right?
It was more modern, and also it did the motor was turning on and off. So
yes,
so you didn't have any wear on the disk because of that. This one had to implement something different because the motor is always on.
Ah.
So they're limiting the wear on the disk by loading the head.
Should I do motor on and should I load the head?
Aha, the 8-inch drive we had tried before was more advanced and PC compatible. Like a more modern drive, the heads are simply dropped on the disk after insertion by the door lock handle. Then the computer just turns on a low voltage DC motor to spin the disk when it wants to read it. But our CDC drive is way older and has an always-on AC motor. The heads need to be loaded by the PC motor-on signal instead. But I thought I had wired that.
So we're making some forensic progress here. We found what our drive is. It's a Control Data Corporation model 9406. And it has a whole freaking bunch of options on here. And here are the million options. They are not on switches, actually. They are configured permanently, either on or off. So there's this one, there's this, there's that. When the little things are open, the option is off. When it's continuous, the option is on. It tells you also what the full configuration they have. And it turns out ours is not the full configuration. It's head load with in use instead of the head load signal. And then somewhere else we found that in use is on pin 18. No, sorry. In use is pin 16. And on the cable I made, we have connected the regular connection, which is pin 18, which is head load. You would use head load for head load. And what the HP drive use is in use, which is pin 16, which is not connected. Therefore, we're going to put a switch, manual switch on it. So here's our modified cable, and that is pin 16, and that should do in use. And so one of these positions should load the head. Hopefully, we think.
Everything's connected.
Okay. So you want me to try to do the head?
Yeah, let's do it. Oh, do it again.
It did the door lock, it didn't do the head.
It does the door lock. And the LEDs are.
Oh, because that's selected.
Oh.
So what I'm going to do is actually lock it, put it in use, and see if that will allow me to access it now from Omnidisk.
Oh, it's loaded.
Oh!
It just did load.
Excellent. Oh, I have 0.8 amps on the 24 volts, so now it's...
Oh, yeah, it just seek.
Yeah, so...
Oh, so yeah, there it is. There's the data.
Oh! We got it.
We got it. It just had to seek, so it was timed out from
something, you just got it for 26 sectors. It's got the 26 sectors. Oh! This one is only one head.
Yeah, it's a one-sided disk.
Right. You think you can use ImageDisk and maybe read it?
Well, let's try it.
Okay. Setting S. Drive A, cylinder 77. Read disk into file. Oh yeah.
It does stuff.
It's working fine.
At this point we got it working in reading, but it would not be fully operational until Antoine developed the final adapter. It is available to everyone on Tindie and comes with jumpering options to address the differences between 8-inch drives and their later 5¼ inch cousins. There are over 11 areas where 8-inch drives differ, and I think I got in trouble for every single one of them. So it's worth spending some time looking at the adapter in detail. Here is the schematic of Antoine's adapter, with the standard 34-pin floppy connector to the PC on the right and the 50-pin connector to the 8-inch floppy on the left. Half of the pins are ground, so we can ignore these. Let's go through the signals that connect easily first. SS is head select, which connects to the pin of the same name on the other side. The PC generates the correct signal to toggle between the upper and the lower head. However, this brings us to the difference number 1. Some 8-inch floppies are single-sided and others are double-sided. Drives that support both standards will detect what type is inserted thanks to the location of the index hole. The drive will then indicate which type of diskette is inserted using pin FD2S. However, there is no support for single-sided drives on the PC, so we leave it dangling. In fact, a PC will get very annoyed with a single-sided disk, thinking it lost the signal from one of the heads. The only way to read and write single-sided disks on a PC is to run specialized tools like ImageDisk. Next is the RD line with the read data. There is an equivalent on our drive, so no issue here. Next, WP is the write protect signal. It also connects straight through. However, beware of difference number 2. Write protection works reverse on 8-inch floppies. On an 8-inch floppy, a disk is write protected when there is no tab across the notch. You can only write to it when you cover the tab with a sticker, which of course is the exact opposite of 5 1/4 PC disks. Guess how I found out. Moving on, track 0, write enable and write data connect right across, so no problem with these. Same goes for step and direction. These are the lines that control the stepper motor to seek the head. These two lines make it very easy to check if a drive seeks. You don't even need a computer. Just shortly ground the step line to the ground and the head should move one step, with the direction depending on whether the deer line is grounded or not. The index line provides a pulse every time the index hole passes in front of the photo detector and marks the start of the track. No problem here, it connects to the equivalent line. Now we come to difference number 3, which is a vexing one, drive selection lines. On the 8-inch floppies there are 4 address lines, so you could have 4 of them connected to a single controller as A, B, C and D drives. But on the PC side, it's a royal mess. PCs have only A and B drives. To make things worse, PC designers hijacked the 2 remaining address lines to make them motor control lines. So we have motor A, drive select B, drive select A, and motor B. But wait, that is only if you have a straight cable. The PC designers decided that it would be an unsurmountable task for a user to configure a drive with a clearly marked jumper, so it would respond to the A or the B select line. In their infinite wisdom, they decided that all drives would be jumpered to the same default as drive B. Yes, you heard right, the default is B, not A. Remember, that's to make life simpler for us, the ignorant users. So to make a drive appear as an A drive, they use a cable with a twist, which inverts the A and B lines. So when the computer tries to access the A drive, unbeknownst to it, it actually triggers the B line through the twist, and the B drive responds as an A, which is obviously much better for the user, which life will be improved by this great decision, because it is not confusing at all. So in order for our external 8-inch drive to respond as drive B and not conflict with our internal drive A, one possible way is to use the B line and a straight cable. Then we put a jumper on Antoine's adapter in the DS1 position. This will connect the signal to the DS1 address select on the floppy. We then need to configure our floppy to respond to the DS1 address. In our case, this was accomplished by flipping the second microswitch here. Alright, now we got the address select sorted out, but what do we do with the motor B line? This is difference number 4. Early 8-inch drives, including ours, do not have motor control, it's always on. Instead, they control the loading and unloading of the heads. Fortunately, Antoine thought about it. the motor B wire gets routed to 2 jumper blocks, giving you the option to wire it to head load or door lock or both. If our drive had the default configuration, the wires would have done what they said, and by connecting the motor on to head load via the header, we'd be done. But sadly, it did not. Far from it. It had many configuration changes from the default. In fact, every highlighted line differs from the default. And what about the door lock then? That's difference number 5. In the old 8-inch drives, you need to activate a mechanical door lock while you access the disks, so you can't accidentally remove the disk while the heads are loaded. This also prevents from changing the disk without the OS knowing about it. The door lock feature got removed for cost reasons on the PC drives. But in an 8-inch drive with loaded heads, you would certainly want to jumper the door lock header. Our case was more complicated. Our drive had an optional in-use line connected to pin 16, which had complicated internal logic from other signals, so it could decide on its own when to lock the door, light the LED, and load the heads. So, long story short, after I deciphered the super complicated options, the way to make our drive work was to jumper the door lock header. Next comes the disk exchange wire. That is difference number 6. The original 8-inch drives are straight shooters. They know when the disk is in and when the disk is out. And since they have a door lock, they can enforce that the disk is not taken out at the wrong time. So they just report disk ready if there is a disk in there and not ready if it's not there. I like that. But we already saw that the door lock feature was deleted on PCs, so knowing there is a disk in there is not enough. It does not guarantee it's the right one. It could have been changed for another disk at any time. So the PC introduced the disk change signal instead. This signal is only active the first time the drive is accessed, if the door has been opened and reclosed and the disk is present. Same happens if a power reset has been detected. After that, it becomes inactive for all of the next disk accesses. This way, the OS can detect if a disk has been changed, and it does not need to lock it. So the correct jumpering on a PC is always to disk change. By the way, a PC will get hopelessly confused if you jumper it to the disk ready signal instead. It will think that you are keeping changing the disk over and over, and it will give you the disk not ready error, even though there is clearly a disk in there. Next comes difference number 7, write current, controlled by the TG43 pin. On early diskette media, the write current had to be reduced on the inner tracks past track 43. That requirement disappeared when better magnetic media became available. So this obsolete signal got hijacked by PC drives to deal with the dual density drives, forcing the drive to change speed for the appropriate disk type. So we leave that one unconnected. Phew, that's it for the adapter settings. This is tragically complicated. But wait, there is more. We have 4 more quirks to deal with. Issue number 8 is the pull-up resistors. When these disk drives were invented, there was no such thing as a tri-state bus. Instead, they used pull-up resistors to 5 volt on shared lines. But there is an issue with that. Early drives use very low 150 ohm pull-ups. Most modern PC controllers can't drive enough current to pull them low. And sure enough, our drive schematics showed the infamous 150 ohm pull-ups, so I needed to change them. They were all contained in a small array package that looked like an IC. But looking closer, the resistor pack was not original, it had an HP number on it. HP had already switched them to 600 ohm resistors. However, if your diskette has 150 ohm pull-ups, you will likely have to replace them with something higher. Next issue on our list is number 9, the 500 kHz bitrate. PCs support different bit rates depending on the diskette density. The low density diskettes spin slower and run at 250 kHz. We need to force the PC to expect 500 kHz instead, or it will give us the dreaded floppy fail error. However, that's easy to accomplish. You just need to set your BIOS to expect a high density 1.2 meg floppy on B, not a 360K. The high-density floppies have the same rate of 500 kHz, so this will do the trick. No more floppy fail at boot. On to issue number 10, FM modulation support. That refers to the scheme used to encode the bits on the drive. The original Type 1 single density 8-inch floppies used FM modulation. This is what our IBM disks from the Fossil episode had. Unfortunately, not all PC floppy controllers support this ancient format. On my Pentium 2 Dolch, the controller is able to read FM disks, but I cannot write to them. So I was still able to recover our paleontologist's data, but I could not recreate an old FM disk image for an IBM mainframe with this setup. And last but not least on our list, difference number 11, the number of tracks or cylinders as they call them, which is simply the number of positions that you can move the head to. PC disks have either 40 or 80 tracks, but 8-inch disks have neither. They have 77 tracks.
So you have to be a little bit careful because they have only 77 tracks. So you have to tell the program. So this is IMD ImageDisk, which is one of my favorites. And here, if you want to work with a diskette to make an image, the first thing you have to do is go to settings and drive. You change it to B because it's on the B drive, and here cylinders you have to go to 77 here and make sure it doesn't try to seek behind that. Sides, this is double-sided, double step off, and now you should be good to go. And if I do read into file, test, insert this to read, dum-dum. And now it's going to happily do the read of the diskette. So I'm going to abort that. So for Omnidisk, it's similar. You have to set it for drive 1, that's the equivalent of drive B. You want to tell it it's 77 cylinders. We're going to map it and scan. And it's going to find out what's on the diskette in terms of cylinders and sectors and encoding. So it's an MFM disk with 15 sectors, so it's a DOS disk. So same thing, you have to tell it it's 77 cylinders. Which brings us to an interesting thing. What if you want to play with it in your PC and want to format it? My favorite utility for that is end format. You want to choose 1.2 megabyte and you want to edit it and make sure you change that to 77, and that's all you have to do. So now it has 77 tracks. It's down to 1.15 megabytes, and press a key and it should go and format the thing. If you don't have any of those tools, you can still do it from DOS. You do format B F 1.2. You format it as a 1.2 meg diskette. So DOS will do it, but at the end, and I don't like that, it just bumps the head. Now you can hear it bumping. No sectors there. But it'll still complete, it'll still do it. It's just fine. It's not elegant, but it works. And under Windows 98, it just appeared as a 5¼ inch floppy. It doesn't know any better. So it's a 1.2 megabyte diskette. And you can also format it from there. You just go format. And it will do the same thing as in DOS. It will start and it'll be fine, and then it'll bump the head into the stop when it goes past 77. You can hear it. It's hitting the end cylinders. Okay, it does a cleaner job than DOS. Doesn't insist too much. And then once you're there, it's just a regular disk. You use it like anything else you want. Put the music file. There we go. There you go. So then you can just use it as a regular disk to your heart's content. Let's see if we can play Kong on an 8-inch diskette. It's loading. So this is 1.2 megabytes, so it's big enough for a game and a DOS installation minus the sound drivers. I figured out it was more fun with sound. Okay, start game. And I'm absolutely horrible at Kong, as it's called. See how far I make it. Probably not very far. Okay, I'm dead already. But you get it, you can run a PC off an 8-inch diskette. This is a pretty good format.